Unit 5. The value is the smallest. Lab requires this match of hexane as a solvent according to the stockroom. This is the molar mass. How many grams is required for the experiment? Okay, so we're going to have 86.172 times 1.5 is 130 grams. 129 grams. Sorry, rounding error. 129 grams. A chromed motorcycle vehicle contains 142 grams of chromium. How many moles of chromium does the motorcycle contain? Okay, so it contains 142 grams, 1, and so we're going to need the grams per mole. It gives us the amount of moles. Periodic table. How many grams of chromium? So Cr probably here, yeah. Cr molar mass is 52. 52 grams per mole. We have 142 divided by 52. 142 divided by 52. How many moles does it contain? 2.73. Nitric acid quickly corrodes copper, producing sulfur, nitrate, sulfur dioxide, and water. Student places a copper coin with a mass of 2.73 grams in a solution of nitric acid. If the coins completely react with excess hydrogen, nitric oxide, no, that's not nitric oxide, nitric acid. Yeah, nitric acid. How many grams of nitric oxide are produced? So, we have a coin. We have a coin that weighs 2.73 grams of pure copper. The grams over 1. How many grams of nitric oxide produced? First, let's figure out how much water, or how much this copper, was it copper or sulfur? Not copper nitrate. Yeah, copper nitrate is produced. Well, if we have 2.7, then we have to have how many moles of that? So we have 63. 63.55. So we have a total of 2.73 divided by 63.55. 0.043 moles of this. Okay. Let's see, and then we can separate that to get So we have 3.95 grams of this. For nitric oxide, though. Six, 4, 10, 12. And so this is a 1. I think we can say 3.95. So check them out. Copper divided by its molar mass got 0.043 moles. 1, 1, 1, 1, 1. Thus, I multiplied it times NO2 to get this number, and then multiply that again times 2 because there's 2 right here. Either A or B. Do I multiply 2 by, or divide by 2? I think I multiply it by 2 because that's 2 moles. We're talking about grams. Hey, got that right. Grams, nitric acid. Yeah, I'm so good. Methane and oxygen produce, so we have combustion reaction. Chemist produces 3 moles of this with 7 moles of oxygen. How much excess reactant will be left over? 3 moles of CH4 plus 7 moles O2. Well, first we'll find the ratio. So we have 1 mole of this, CH4 plus 2 O2 yields CO2 plus H2O. So we have 1 of this, 1 of CH4, and then O2, that's 4. So 1 carbon atom, 4 hydrogens, 4 hydrogens, 4 oxygens, 2 oxygens, 4 oxygens, 2 oxygens. So yeah, it's a 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I wonder if that's an emergency phone number. Chemist reacts this, so 3 moles of this, with 6 moles of oxygen. You'll have 1 mole of oxygen remaining. These 7 moles O2 and 3 moles of this, you have 1 mole of oxygen. How much xenon? Oh, that's cool. 1 mole of xenon contains how many atoms of xenon? A ridiculous amount, because that's Avogadro's number. Not 53, that's my protons. Not the atomic mass, but Avogadro's number. How many ionic solids make crystals with specific shapes? For example, potassium 2 sulfide forms a cubic shape in which potassium ions fill the holes between the larger sulfate ion. Which of the following is the molar mass of this? So let's get the periodic table out. So we have K2S. So we have K, so that's potassium, it's going to be here. Our molar mass is 39.1, 0 grams per mole for potassium. And then sulfur is going to be 32.06 grams per mole for sulfur. And we multiply potassium times 2, so we get 39.1 times 2 is 78.2, and we add 32.06, and we get 110.26, which would be grams per mole. Potassium. Yeah, that sounds right. Honorary 71. Maybe just added potassium and sulfur, and then I get 103. Probably did two sulfurs and not 2 potassiums. Certain sample of ammonium dichromate produces 0.159 moles of water when it reacts. 0.159. Assuming the reaction went to completion, how many moles of ammonium dichlorate were in the sample? So it decomposes. Oh, that's really cool. Fire. So we have 0.16 moles. So we have to find the molar mass. No? Oh, moles of water. I see what it's saying. So we multiply that with 0.159 times 1 of this is equal to 4 of these. So we need to multiply it times 0.25, or divide by 1/4. Not 0.3975. Larger mole doesn't make sense. The same amount of moles doesn't make sense. You multiply by 4, that also doesn't make sense. Gas tank has the average automobile holds 37,200 grams. The principal component of gasoline. Oh, that was gonna be a full sentence. It's a dependent clause. Octane combusts. I was so confused. Octane combusts with oxygen according to the following reaction. Assuming all of the octane reacts with excess oxygen, how many grams of CO2 are produced by the average tank of gasoline? I'm saying this is octane. Yeah, so you have combustion reaction, carbon dioxide, water, oxygen. So that's actually not as heavy as I thought it would be. I guess it's a little hydrocarbon. We have 114.224 is octane. That's what we earlier found. So we found. No, we did find this earlier. I found this in a different question a while ago. Over 1 is grams per mole. So we're going to flip this to 114.224 is 1 mole for this many grams. And multiply this times 37,200 over 1. And we get 37,200 divided by 114.224. That gets us 625.6 moles. And this reacts with all the CO2. How much CO2 is produced? So I guess we'll divide this number by 2, multiply times 16, and then multiply times the molar mass of carbon dioxide, which is 44.01, is 115,000. Does that make any sense? $325 times 2 multiply times carbon's what, 16, 12-ish. You get 62,000. That sounds about right. And we're talking about oxygen here. Copper and silver nitrate. The copper solid, and so you stick in copper and you get out solid silver. Oxide reduction reaction. Runs this reaction and produces 0.12 moles of silver. Assuming the reaction went to completion, how many moles of copper were used? So you have 0.12 moles of silver. So you have a copper solid plus aluminum nitrate turns into 2Ag plus Cu moles of copper were used in the reaction. So if we made 0.12 moles of silver, then it made 0.06 moles of this copper salt right here. Which means, first we have to solve the equation, I guess. So if we have, let's have 2 of these. So 1 of silver, that gets us 2 silver atoms, nitrate, 2 nitrate atoms, So 1, 2, 2. It should just be 0.06 moles. Redoubling it, it's not going to say the same. Moles of this. Divide by 2, so we get the standard moles, and that's how many we're in copper. Yay. Such a pretty sound. What level am I at? 55. Life is good.